This is page 290. The second part of the review for chapter 4A, or unit 4A. So number 80 tells me I have the cotangent. Cotangent equals -3. They tell me I'm in quadrant 2, and they want the sine of theta. Okay. I use a trig identity. Personally, I would just build a triangle here. So keeping this in mind here is my quadrant coordinate plane. Okay. So I got to get a couple of things. I'm going to think of my cotangent as that, and I got to remember, I'll just kind of write it over here, that cotangent is equal to the opposite, the adjacent over the opposite. But since I'm on the coordinate plane, I want to think of it as x over y. Okay, so I'm going to draw my triangle out here, and my x coordinate is -3, and my y coordinate is a 1, and that makes sense, right? Because in quadrant 2, I have negative x's and positive y's. Call this theta. Okay, and they want the sine, which would be the opposite side over the hypotenuse. Well, I don't know that, so I'm going to use Pythagorean theorem. So that's 1 squared plus -3 squared equals, call that r squared. If I do all of that, this comes out to 10 equals r squared. Take the square root, and that's what r equals. Okay, so consequently, my sine is equal to the opposite side over the hypotenuse. If I rationalize, okay, and since it corresponds to the sine, or sine and y, that means I'm in the positive y, so this is a positive sine. Okay, that was 80. 82. And 82 tells me the cosine of theta is equal to 5 over 8. I'm in quadrant 1, and they want the secant of theta. Okay, so this one's really easy to use a trig identity. I could build the triangle like I did above, but I think this is pretty simple because if you remember, cosine theta is equal to 1 over secant theta. Okay, so that means I can just plug all this stuff in, or other way around, sorry, secant theta is also equal to 1 over cosine theta. So I'm going to plug into this one, all right, and that would be my answer. So coming over here, I'm going to say secant theta equals 1 over 5 over 8, multiplied by the reciprocal, and then I'll write it down here, secant theta equals 8 over 5. Okay, I could build the triangle just like I did above, but this is easier. You know, just to show you real quick, you know, I'd be over here in quadrant 1. Cosine is defined as the x value over the r value. Okay, and secant from this definition is defined as r over y. So it just literally put the 8 on top of the 5. Either one of those is pretty quick. Okay. 84 says the tangent of theta equals -5 over 4. I'm in quadrant 4, and they want the cosecant of theta. Okay. So once again, there is a trig identity that I could use, but it requires a little bit more at the end, so I'm just going to go ahead and build the triangle. So I'm over here. Okay, I'm in quadrant 4, tangent being defined as y over x. Okay, so I'm over here somewhere. Okay, so this would be a +4, and this would be a -5. Here's my theta, and so I'm going to find the cosecant. I need the hypotenuse. Okay, so cosecant is defined. I can use the 1 over sine, or I can just use the other definition and say cosecant is equal to r over y. So I got the y, I just need the r. So it's going to be 4 squared plus negative 5 squared equals r squared. 16 plus 25 equals r squared. Right? And so that is going to be what? 41. Okay? So that's 41 equals r squared. R equals the square root of 41. Okay? So my cosecant is going to be the y value over the r value over the y value right here. So I'm going to say cosecant of theta equals 41 over negative 5. Okay, and I could put that negative in the top or out front. It's the same thing. Okay, so the quadrants are important because it tells me basically the signs of my cosecants and other stuff. Okay. All right, jumping to number 104. Okay, so it says find two solutions of each equation. Give your solution in both degrees and radians. Do not use a calculator. Okay, so looking at 104. Okay, looking at 104, they basically give me the cosine of theta equals root 2 over 2. Okay. So most of us would probably recognize that that is the same as pi over 4. That's the same as pi over 4. Okay? Because that's right here would be root 2 over 2 and root 2 over 2. Now, remember, cosine corresponds to the x value. Okay, to the x value. Well, if I'm in quadrant 1, the x's are positive, and I'm in quadrant 2, the x's are also positive. So theta, in this case, can equal pi over 4, but can also equal the other one with a denominator of 4, and it's also going to equal 3 pi over 4. And I'm just going to do it in radians. Okay? So basically, I'll tell you, 45 degrees and 135 degrees both have positive cosines because they correspond to the x value. Okay. Well, part B is the cosine of theta equals root 2 over 2. And it's negative in this case. So say now, that would be where do I have negative x's? Okay, oh, sorry, I made a mistake there. Going back. Cosine, so it would have been down here in quadrant 4. Sorry, would have been in quadrant 4. So it's actually 7 pi over 4. Okay. Now for negative ones is over here in quadrant 2 and 3. Sorry, I was thinking of sine. Okay. So that one it would be, sorry, theta would equal 3/4 pi. And my other one would be 5 pi over 4. 5 pi over 4. Okay? So my cosines are positive when I'm in quadrant 1 and quadrant 4. My cosines are negative when I'm in quadrant 2 and quadrant 3. Okay, be careful because I even made a mistake there.